Hello everyone and welcome to my channel. Today we are here to see the second machining operation, which is the cut. So let's start immediately. Machining operations. I've already created a panel and the second one from the top will be cutting. So cutting, of course, we are talking about saw blades, and for the boring machining, there are different types of it. So we click here just to see how many options there are, and we can see that this machining operation can be applied from the geometry. It can be from the endpoint, so just giving coordinates, and from the length. We will see now one by one. So let's start from the top. From geometry, we need a geometry. Of course, since every panel comes already with the master geometry, if I'm just sizing the part, I can select what I need to select basically from the master geometry, then select the tool correction, but we can see it better actually after selecting the tool. So let's go and select the tool. Remember, the green dot is basically informing you that the tool is available at the machine. We can look at from the top, and here it is. So let's focus only on one of them. Central correction, left, right, and again, so central. Now, in my case, I have a 5-axis machine, so the blade, as you can see, is installed on a tool holder. But it is exactly the same thing if you are using the small saw blade, the 120mm on the boring block, if you have it, because it's normally present on especially on pod and rail machines. Or maybe you have an aggregate. So it doesn't really matter, the process is the same. You select geometry, select correction, you select the tool, then of course the depth. So let's look at the panel from the side so we can see where it is. Now is right above the panel because the depth is 0. And if we go 10 or whatever it is, you know, and we see the blade going down. Of course, you always have the through cut that you can enable, and in this case the 10mm will be taken from the bottom of the panel down. So from the bottom of the panel to the tip of the blade will be 10mm in this case. I usually go 2mm or 3 through in case of a pod and rail machine, or maybe even 5. Otherwise, for a flat table, usually you want to go 0.1, so just barely under the part. Another important thing to talk about is the cutting direction. So as you can see, I didn't specify anything, and based on the rotating direction of my blade, which in my case is counterclockwise, but eventually we can go double check. So edit, blade, you see, counterclockwise. So let's disable one. All right, so we can understand better. Counterclockwise, the blade usually wants to climb on the panel. because especially in case of melamine, if you go conventional, it will probably chip the melamine. So the reverse travel eventually will change the starting point of the blade, and as you can see, in case of a 5-axis, the spindle will be above the panel, right? It will be right here. If you reverse it, of course, the spindle will be on the other direction, but the tool will still climb on the panel. So counterclockwise the rotation, starting from the right and going left. Why I have showed you the reverse travel here? Because in case you want to do a conventional cut for some reason, maybe because we are working with solid wood, or I mean for any other reason or any other material, you can change between climb or conventional here in the advanced tab, reverse the cutting direction. So in this case, if we enable this one, you see the starting point didn't change this time, still there, but keep in mind the blade is going counterclockwise, and this time is starting from left and is going right. So in this case, the blade will do a conventional cut. Now that we have seen this, another important parameter here on the advanced for sure is the hood position. You can adjust it accordingly. And keep in mind that if you are using the saw blade on the boring block, if you have it, again, is meant just to be used for grooving, not for true cuts. So just keep that in mind. And normally you don't really need to select the dust hood position, because that is basically part of the boring block already. So going back to the main parameters, here we have seen the depth. Horizontal passes normally is gonna leave the thickness of the blade, so I can leave that, or if I need to make a groove or a dado or something, I can specify a total thickness, which is actually not really the thickness, but is the width of the cut that the blade will make for me. So if we look from the top now, we can see, well, let's select a different correction. So let's select right. We can see now it's gonna leave just the width of the blade, but if I change this one, the total thickness, like, I don't know, I want 10 millimeters, the software will automatically add repetitions in order to give me a 10 millimeter wide grooving. So if we confirm and we see the simulation, well, this is probably too fast. Let's slow it down a little bit. We will see that it's gonna pass 1, and going back 2, 3, and 4 times, just to give me the 10 millimeter. Now probably I went too deep. Actually, through cut enabled, I didn't go deep enough in the simulation, so this is not an error of the graphic, but probably my blade doesn't have the correct diameter. You see, my diameter, it says 300.6, which in reality my disc is actually 300 only. So let's fix it immediately. Adapt the diameter from pick on a drawing, like we have seen during the tool creation. I click and want this point, so now my diameter is 300 millimeter exact. We can save it. It's gonna ask us to confirm. Now, going back into the CAD/CAM, if we play the simulation again, actually, this time it will not leave the dado, but it will cut 10 millimeter from this panel. So we have seen eventually what can happen also. Troubleshooting. Okay, so stop, close. Now I was saying, if we, in case we need to do a dado, of course the depth it will be not true, maybe 10 millimeter or whatever it has to be. Calculate, okay. Play the simulation. Now we can even go fast. 1, 2, 3, 4, and here it is. So stop, close. So remember, total thickness is not really the thickness, but is the width of the cut that you want to get. Then initial and final extension, like for the lead in, lead out, basically. If we look it from the top, right now the blade is starting with the center of the blade on the starting point and finishing at the end. If we wanna add an extension, like the word says, we can come here and add whatever we need to add. 100, 100, you see that is extending the cut. Then vertical step, in case of a saw blade, from my experience is only used in one case, which is to avoid chipping the bottom of the panel. What that means, so let's actually go back to only a single cut. Normally, and actually let's move the cut inside a little bit. Let's confirm for now, turn it off. Since we're still talking about the cut from a geometry, I can eventually create an additional geometry. I mean, it can be any line in any direction. Of course, any direction if I have an aggregate with a z-axis at least. or the 5-axis, like in my case here. Otherwise, it is based on the cutting direction of the aggregate or based on the position of the blade in the boring block. So it is really important to understand that everything is possible in the software, but then you are able to do it only if the machine is configured properly. So line, we can actually copy and paste the same machining. Ctrl C, Ctrl V, cancel. So now we got the second one with pretty much the same parameters, and I can apply it to my new line. At this point, well, let's say that I'm cutting this panel, in 2 pieces like that. So let's maybe extend the cuts a little bit more, just to make sure I'm gonna cut it and separate completely the 2 parts. And in this case, what is gonna happen? So let's say that I'm cutting a panel with a melamine, top and bottom. Play the simulation. Let's slow it down. So remember, my blade is counterclockwise. So it's climbing on top of the panel. But since it is a through cut, of course the teeth at the bottom of the panel will be still pushing down, and so will chip the bottom of my panel. So stop. All this was just to hopefully make you understand the concept properly. So the vertical step, it will be 2 vertical steps, and I will have to enable the 2 directional passes. So as you can see now, let's confirm, the blade is going down, does the first pass basically halfway into the panel, and when it gets to the end, it goes down and comes back in the opposite direction. What that means? That I will be climbing, in this case, on top, because right now my teeth are going in this way and pushing basically the melamine down into the material. And since I'm not all the way through, when the blade gets at the end, it goes down and comes back. So in this case, consider that I'm still spinning, of course, in the same direction, counterclockwise. In this case, my teeth will push up my melamine. Of course, the top is already cut, so it will not chip, and the bottom will not chip either. Stop, close. Pretty much, I think we have seen everything. Let me see. Of course, speed data. So, by default, the fits and speeds are taken directly from the tool. Whenever you create, the tool is there where you decide what is the standard feed rate and the standard RPM, the plunge rate, and so on. And that is what the software will take by default. Otherwise, you can play between those parameters directly from here, from the machining into the program. Then safety data. So same thing, it takes directly the safety from the tool, or you can disable and change it. Just as a suggestion, usually never go down, so never decrease the safety, but eventually add some. And the last tab is actually machining data, where again, especially if you have a 5-axis machine, you have the ability to do that. But if we check the panel from here, we can see that right now the blade is straight, but we can change the angle. So 45. Of course, this will be not possible because the spindle will be upside down, but maybe something less it will. Or of course you can go negative. Or 45, or whatever has to be. So with the excess material, it's probably better to see from the top, we can stay away from the selected geometry, 10 mm in one direction, 10, it can be even 100, I mean, can be anything. It's just basically an offset from the geometry selected, or it can also be negative if you want to go on the other direction. We have seen all the parameters, so I'm not gonna repeat them for the next types. Just so we can see also the other cutting types, I'm gonna now select the second one from the endpoint. So in this case, it just go by coordinates without any geometry need. So I want to start, and remember, this is the reference corner, which can be changed or added in case of same direction of cut and same coordinates, you know, like we have seen in the previous video for the drilling. So starting point, considering the reference corner, which is this one in this case, 0, 0, and for the end point, I don't know, 200, 300. So select the tool and we are able to see what we have done. Of course, keep in mind that this type of cuts are only possible with aggregate with a C-axis at least, or a 5-axis machine. But otherwise we can go just X, Y, or basically on the standard directions. So from 0, 0, we can even say, okay, go for the length of the panel. So length of the panel in X. So all the other parameters are the same. I'm not gonna explain them again. So we confirm and we can see the last one, which is basically the same thing from the length, which still needs the starting point, the coordinate for the starting point. I don't know, it can be 100 in Y and 0 in X. Let's select immediately the saw blade, so eventually we can see also immediately the result. And specify the length. So 500. In which direction? So if you leave a 0, it will go along the X. Otherwise, it can be 45 or 90 or 270, 180, and so on. So we have seen how to use the cut in machining. In the next video we will see the milling. So stay tuned for new videos.